It's 1943. A searing Pacific sun burns across the island of Espiritu Santo. Waves crash against the coral shore as the roar of diesel engines drowns out the jungle's hum. Dozens of men, shirts off, backs bent, feed jagged volcanic rock into a crushing machine that rattles like thunder. Clouds of gray dust rise, coating every face, every uniform, until everyone looks the same color: stone. A lone graveler adjusts the machine's settings, eyes narrowed through the dust. He isn't a soldier in the usual sense. He's a builder, one of the U.S. Navy's Seabees, turning raw island rock into lifelines for warplanes. Around him, piles of crushed coral spill like rivers of ash, forming the bones of a new runway. From the beach, a line of half-built airstrips stretches into the horizon, flat, hard, and vital. Within days, fighters and bombers will roar from this ground toward enemy strongholds. This isn't just construction. It's the quiet front line of the Pacific War, where crushed rock became the foundation of victory. When the Pacific War erupted in 1941, the geography itself became one of America's greatest enemies. Thousands of islands scattered across vast blue emptiness, each one isolated, humid, and unforgiving. To win, the Allies had to leapfrog from island to island, building air bases faster than the enemy could react. This became known as the island hopping strategy, a brutal race for reach and control. Every successful landing needed an airstrip. Without it, supplies couldn't move, fighters couldn't protect convoys, and bombers couldn't strike the next target. But the Pacific wasn't Europe. It was a wilderness of coral reefs, volcanic cliffs, and thick jungle. Traditional construction methods simply didn't work here. Cement couldn't be shipped in large quantities. Heavy equipment sank in soft sand. Rainfall turned everything to mud. By early 1942, U.S. engineers faced a dilemma that threatened the entire campaign. They could land on an island, but they couldn't keep it. Without stable airfields, each victory was temporary. Commanders demanded speed, runways that could handle B-17 bombers within days, not weeks. Enter the Naval Construction Battalions, better known as the Seabees, a fusion of skilled civilian builders and trained Navy men. They brought bulldozers, graders, and an inventive spirit that thrived under pressure. Their mission? Make the impossible operational. On the island of Guadalcanal, they inherited the chaotic remnants of a half-built Japanese airstrip. The terrain was unforgiving: loose coral, uneven lava rock, and suffocating humidity. But the Seabees learned something from their enemy. The Japanese had been using local coral and volcanic rock as a foundation for their runways. Crushed properly, it could compact into a surface hard enough to handle aircraft weight. The Americans studied, adapted, and refined that method with remarkable precision. The process began with scavenging. On beaches and inland hillsides, teams collected coral and volcanic stone, whatever was available. They used portable rock crushers, some built from scratch, others repurposed from mining equipment, to grind the raw material into graded gravel. Then came the layering: coarse coral at the base, finer crushed rock above, compacted again and again with rollers and heavy vehicles. The result was astonishing. Within 48 to 72 hours, a stretch of jungle could be transformed into a functioning airstrip. The crushed coral not only hardened under pressure, it also drained rainwater efficiently, preventing the mud disasters that plagued early efforts. Reports from Guadalcanal, Espiritu Santo, and Tarawa spoke of near-miraculous speed. Where traditional runways might take months, these improvised coral strips appeared in days, Every new method, every improvised machine, saved lives. Each hour counted. The sooner planes could land, the sooner the next island could be taken. But this innovation wasn't born in a laboratory. It emerged from necessity, sweat, and human instinct. Men learned by failure. When one coral mix turned too soft under the rain, they changed the ratio. When a crusher jammed, they re-welded it overnight. The Seabees became not just builders, but engineers of adaptation. By mid-1943, the technique was spreading fast. Manuals were printed. Diagrams circulated across Pacific bases, from the Solomons to the Marshalls. The rock crushing process, and as it became known, was no longer a desperate improvisation. It was a system. The Seabees standardized portable crushers, mixing procedures, and compaction tests. Each new island was a blank slate, waiting to be carved into steel-hard coral runways. And yet, behind every machine and pile of gravel stood the same figure, the graveler. A man with a shovel, a loader, and an eye for the right texture of crush. Ed Stone. He knew, instinctively, what grade would bear a bomber's weight, what sand would wash away, and what would stay solid under monsoon rain. His skill turned chaotic earth into engineered precision. These men built in the shadows of war, under air raids with limited sleep, surrounded by danger. But their work was the heartbeat of the campaign. For every spectacular dogfight in the skies above, there was a quiet victory below, won by the sound of grinding rock. The Pacific Theater was no longer a naval chessboard. It was becoming an engineer's battlefield where invention determined survival. By late 1943, the Pacific was an enormous floating workshop. Every island under American control became both a launch pad and a construction site. Cargo ships carried not only weapons and ammunition, but graders, rollers, crushers, and fuel drums for the Seabees' relentless work. The gravelers, as they were informally called, moved like nomads, setting up portable crushing plants wherever coral or volcanic rock was found. The operation was a marvel of logistics. In places like Tarawa, the coral was white and soft. On Guadalcanal, it was mixed with volcanic basalt. On Saipan, dense lava stone dominated the landscape. Each island demanded a new formula. Engineers learned to measure the crushing density, adjusting for climate, rainfall, and altitude. The coral's natural calcium carbonate made it uniquely suited for compression, but only if crushed at the right grain size. Too coarse and planes bounced. Too fine, and tropical rain reduced it to sludge. They developed field tests with simple tools, a jar of seawater, a handful of crushed coral, a stomp of a boot heel. If the mix held firm, it was good enough to build on. Precision engineering through pure instinct. The U.S. Navy construction battalions built not just runways, but entire forward bases, hangars, fuel storage, hospitals, even ice plants, always anchored by that first layer of crushed stone. In some operations, the first planes landed while the far end of the runway was still under construction. At Munda Point and Bougainville, bombers took off from freshly compacted coral, lifting over jungles that were still being cleared by bulldozers below. This new speed in airfield construction began to reshape strategy. Commanders realized they no longer needed to capture large, developed islands. Smaller, undeveloped atolls could be transformed into full operational bases within a week. This allowed the U.S. to leapfrog over heavily fortified Japanese positions, bypassing them, isolating them, and cutting off supply lines without direct confrontation. In practical terms, the Seabees' gravel process turned the Pacific Ocean into a highway. Bombers could now hop from one airfield to the next, steadily extending America's striking range toward Japan. Each crushed coral runway was a stepping stone: Guadalcanal to Tarawa, Tarawa to Kwajalein, then Guam, Saipan, Tinian, and beyond. The technical breakthrough lay not in a single machine, but in the system they created. Portable crushers, some weighing only a few tons, could be disassembled, loaded onto landing craft, and reassembled within hours on new terrain. Seabees often used spare tank engines to power them, improvising drive shafts and belts from salvaged materials. Everything about the process was practical, field-engineered, and brutally efficient. In the heat of the islands, men worked 12-hour shifts under enemy fire. Japanese snipers targeted bulldozers. Bombers strafed unfinished runways, yet construction rarely stopped. They worked by torchlight when needed, sometimes compacting gravel while shells landed offshore. The priority was absolute. The first aircraft had to land as soon as possible. By 1944, reports from the Navy Bureau of Yards and Docks described the method as a decisive advancement in forward airfield construction. The insane speed of production stunned commanders used to European timelines. In the Pacific, a team of 200 men with 2 crushers and a few rollers could build a 5,000-foot airstrip in under 10 days. Concrete, in the traditional sense, became almost unnecessary. The crushed coral, mixed with small quantities of lime or cement when available, hardened into a concrete-like surface naturally. In some cases, engineers experimented with coralcrete, a mix of coral dust, sand, and seawater, which hardened further under sunlight. Nature became the Seabees' partner. This combination of improvisation and precision changed everything. A process that began as trial and error among isolated gravelers evolved into a doctrine. The U.S. Navy published detailed manuals describing grain sizes, compaction ratios, and coral classifications. Entire engineering schools back home began studying samples from the Pacific. By the time U.S. forces prepared for the Mariana Islands campaign in mid-1944, the system was perfected. Hundreds of Seabees landed with prefabricated crushers and standardized construction sequences. On Saipan alone, they laid down 3 full airstrips in record time, each capable of launching B-29 superfortresses bound for Tokyo. In just 2 years, the war's slowest front had become its fastest-moving theater, all built on rock dust and human endurance. The graveler's process, once seen as crude improvisation, had become one of the most crucial engineering innovations of World War II. And as the island hopping advanced closer to Japan, that same grinding roar of machines echoed again and again across new shores, each one the sound of progress and the promise of eventual victory. The Pacific War was fought not only by soldiers with rifles, but by men with shovels, hammers, and sheer determination. The Seabees, those gravelers working under the punishing island sun, were the war's hidden warriors. Their battlefield wasn't a trench or a sky full of bombers. It was the raw earth itself. Every grain of crushed coral they produced carried the weight of a mission waiting to fly. They were mechanics, miners, engineers, and laborers all at once. Many were older than the average soldier, some in their 30s or 40s, with years of construction experience back home. They built runways with the same hands that once paved roads and laid foundations for houses. But here, each project had the urgency of survival. Every delay meant grounded air, craft, stalled offensives, and lost lives. They often worked in brutal conditions. On Bougainville, the air hung heavy with 90% humidity, and rain turned crushed coral into blinding white mud. On Tarawa, Japanese snipers harassed construction crews, while the sound of crushers masked distant artillery. Still, the Seabees pressed on, often with cigarettes clenched between teeth and bandanas soaked in sweat and dust. At times, they built directly under attack. Bulldozers kept moving even as enemy shells landed nearby, because stopping meant giving the enemy another chance to regroup. On Guadalcanal, a Seabee crew kept their crushers running through a night raid, feeding rock by flashlight, knowing that the dawn would bring both bombers and enemy planes, each depending on what they could finish before sunrise. Their work demanded rhythm. One man operated the feeder, another shoveled the excess, a third checked the aggregate size by hand. The noise was deafening, the engine's growl mixing with crashing waves and distant explosions. But there was pride in the monotony. To them, each crushed stone wasn't just material. It was progress. When planes finally landed on their new strips, dust swirling, engines screaming, every man stopped for a moment to watch. That sound, the thundering takeoff of a fighter or bomber, was their proof of victory. They didn't fight for glory. They fought to make flight possible, to turn raw islands into lifelines. And for the men on those runways, that was enough. What made the Graveler's process truly revolutionary wasn't just human endurance. It was how simple mechanics met military precision. The machines themselves were unremarkable by civilian standards. Small portable rock crushers, often powered by diesel truck engines or modified tank motors. Yet, in the Pacific, they became the most valuable equipment after the bulldozer. Each crushing unit was designed for mobility. When Seabee battalions landed on an island, they carried these machines in sections, reassembling them within hours. Once operational, they chewed through coral and lava rock, producing hundreds of tons of graded gravel per day. There was no concrete mixer, no factory, just machinery, manpower, and ingenuity. The process followed a pattern perfected through repetition. First came clearing, jungle leveled by bulldozers. Then, the crushers began their roar. The broken rock was screened, layered, compacted, and soaked with seawater to harden under the tropical sun. Each layer was tested by driving heavy trucks across it. If the surface didn't buckle, it passed. By the final compaction, the runway gleamed pale white, smooth, firm, and ready for warplanes. From a tactical standpoint, this speed was transformative. Air power dictated victory in the Pacific. The faster an airfield could be built, the faster an island became a fortress. Fighter squadrons could protect advancing fleets. Bombers could strike deeper into enemy territory. Commanders began to time invasions not by infantry progress, but by when the Seabees would finish a runway. The process also gave the U.S. an immense psychological advantage. Japanese intelligence frequently underestimated how fast Americans could rebuild airfields after an attack. On Tarawa and Guam, airstrips bombed to rubble were restored within days, because the same crushed coral that shattered under bombs could be reclaimed, recrushed, and reused. Nothing went to waste. Strategically, it was a chain reaction of efficiency. Portable crushers allowed mobile warfare. Mobile warfare required new logistics, and new logistics demanded fearless builders. In the space of a few years, American engineers had transformed coral reefs into global runways. It was a miracle of simplicity. Machines, men, and rock working in rhythm. A system so effective it erased the boundary between construction and combat. And soon, that system would be tested on the grandest scale of the Pacific War. The first true test came at Guadalcanal in late 1942, when U.S. Marines seized the half-finished Japanese airfield at Lunga Point. They found chaos, shell craters, tangled machinery, and rain-soaked coral. The enemy had fled, but nature remained the greater foe. Within hours, Seabees and marine engineers began the impossible: restore the strip while fighting off nightly bombardments. Working by hand and with scavenged equipment, they crushed coral through salvaged Japanese rollers and makeshift crushers. The noise carried through the night as naval gunfire thundered offshore. Men shoveled under flares, the white dust blending with smoke. Within days, they finished what the Japanese had started. On August 20th, 1942, the first American aircraft, F-4F Wildcats, lifted off from the newly named Henderson Field. It marked the first American airbase built and defended entirely in enemy territory. That success became the model. By 1943, at Tarawa, Seabees landed only hours after Marines secured the beachhead. Enemy bodies still lay among coral ridges as crushers began grinding. Under sniper fire, they built a 4,000-foot runway in just 3 days. The crushed coral, bright, hard, unyielding, turned the tiny atoll into a forward air hub for B-24 bombers striking the Marshalls. The innovation spread rapidly. At Saipan in mid-1944, engineers constructed massive airfields like Islay Field, capable of hosting B-29 superfortresses, the largest bombers of the war. These aircraft, weighing over 60 tons, demanded surfaces of extraordinary strength. Yet the same coral crushing process, refined and scaled, delivered exactly that. The runways gleamed white in the sun, built atop volcanic ash, coral dust, and determination. Every crushed stone now served a larger purpose. Each new airstrip extended America's reach by hundreds of miles, bringing Japan closer within range. What began as improvisati had become a military doctrine, the art of turning islands into weapons. But the Seabees' greatest test still lay ahead. On islands where the stakes were higher, the defenses stronger, and time was measured not in days, but in lives. By late 1944, the Pacific Campaign had become a vast choreography of construction and combat. The Seabees' rock-crushing miracle now powered the Marianas, the Philippines, and Iwo Jima, islands that would define the war's final outcome. Each landing brought the same rhythm: invasion, resistance, and then the steady roar of crushers beginning their work before the smoke even cleared. On Tinian, the process reached its zenith. The island's terrain was rough volcanic plateau, covered in sugarcane and riddled with coral limestone. Yet, within 45 days, Seabees carved out North Field, the largest airbase of World War II, 2 parallel 8,500-foot runways capable of launching hundreds of B-29 bombers toward Tokyo. They crushed over 900,000 tons of coral rock, layering and compacting it until the surface shone pale under the tropical sun. From those runways, the Enola Gay and Boxcar would later take off, carrying atomic bombs that would end the war. At Iwo Jima, the stakes were even higher. Marines fought yard by yard while, behind the lines, Seabee teams began building a temporary strip using the same coral-crushing process, even as the island was still contested. Volcanic ash made compaction nearly impossible, yet they mixed it with coral and scoria until it held. Within days of the island's capture, the first P-51s and damaged B-29s began landing there, saving thousands of airmen whose aircraft couldn't make it back to base. This was the turning point not of a single battle, but of the entire Pacific War. Engineering had become as decisive as firepower. The ability to crush rock, lay coralcrete, and build a runway under enemy fire had transformed logistics into strategy itself. The roar of crushers became the anthem of progress, one that marked every mile toward victory. For every tank that landed, and every plane that flew, there was first a team of gravelers shaping the earth beneath them. And as the Pacific closed in around Japan, those runways, 50 and more by war's end, formed a white arc of crushed coral and steel that would carry the war straight to the enemy's doorstep. When the war's dust began to settle, the numbers told a story that few outside the Pacific could truly grasp. By 1945, the U.S. Navy's construction battalions had built or repaired over 50 major airstrips across the Pacific, stretching from the Solomons to Okinawa. Many of them were constructed in record time using the same coral crushing process born out of desperation only 3 years earlier. Each runway was a milestone of logistics. Some stretched for miles across once hostile jungle. Others rested on atolls barely wider than the landing gear of a bomber. Together, they formed a chain of concrete and coral that carried the war to Japan's doorstep. The Seabees had transformed the Pacific from a vast ocean barrier into a ladder of airfields. Military records describe staggering achievements. 1 million tons of coral rock crushed and compacted. More than 300 airstrips, large and small, completed or maintained by Seabees, and countless auxiliary roads, taxiways, and storage yards built with the same material. Each ton of gravel represented sweat, innovation, and relentless precision. At islands like Guam, Tinian, and Saipan, the finished airfields became permanent symbols of victory. Even after the war, many remained operational, proof of how strong the coral concrete process truly was. When engineers tested some of those runways decades later, they found the compacted coral still intact, still bearing weight. But the real triumph was speed. Where engineers once measured construction in months, the Seabees reduced it to weeks, and sometimes days. That acceleration saved lives, shortened campaigns, and gave the Allies unmatched air mobility. In official Navy reports, one officer wrote, "The miracle of our progress is measured not in ships or shells, but in square feet of runway." He wasn't exaggerating. The crushed rock of the Pacific became a weapon in itself, a silent one that made all others possible. And though the war would soon end, the engineering legacy of those gravelers was only beginning to reveal its impact. After Japan's surrender in August 1945, the Seabees' work seemed to fade quietly into history. Their machines went silent, their camps dismantled, their coral quarries reclaimed by jungle and tide. Yet the legacy of their gravel-crushing process outlived the war itself. The method had changed how militaries thought about construction, proving that infrastructure could be as decisive as any weapon. Post-war engineers studied the coral runways with fascination. Civilian contractors adopted similar crushing and compaction techniques in tropical regions, from Micronesia to the Caribbean. The process influenced the design of modern quick-build airfields and emergency landing zones used in later conflicts, from Korea to Vietnam. In many ways, the Pacific Seabees had pioneered what we now call rapid deployment engineering. The U.S. military institutionalized their lessons. Manuals on coral aggregate base courses and portable crushing operations were published, referencing field notes written under fire. What had begun as instinct in 1942 became formal doctrine by 1946. But the most powerful legacy was human. Many gravelers returned home to construction jobs, road work, or quarry labor, ordinary men carrying extraordinary experience. They'd learned to build under fire, to make the impossible functional, and to see potential in chaos. When interviewed years later, one Seabee simply said, "We didn't build monuments. We built what others stood on." Across the Pacific, remnants of their work still remain. Some coral runways serve local communities, others lie hidden beneath vegetation, faint white scars on aerial maps. But for a few, like Tinian's North Field, they stand intact, massive, quiet, and enduring. Those crushed stones, hardened by time and heat, became more that, and the foundation of aircraft. They were the groundwork of victory, proof that ingenuity and labor could outbuild the enemy as surely as any army could outfight them. And in the echo of those machines, the Pacific still remembers the sound of progress, the grind of coral, the hum of engines, and the will to keep building even when the world was breaking apart. In every war, history remembers the generals, the battles, the victories. But behind every triumph lies the quiet labor of those who built the ground beneath it. The gravelers of the Pacific never fired a shot in anger, yet their work carried the weight of the entire campaign. With shovels, crushers, and unwavering resolve, they transformed the raw earth into the runways that delivered freedom. Their process was never glamorous. It was dust, heat, and exhaustion. A war fought with machines against nature itself. Yet from those humble efforts rose the very foundation of modern military engineering. The coral airstrips they built allowed bombers to bridge oceans, fighters to protect fleets, and wounded men to return home. Every mission that left those islands carried a piece of crushed coral in its success. In the grand story of World War II, the Pacific's coral runways might seem like small details, but they were the stepping stones to victory. They proved that innovation is not born in comfort, but in necessity. That progress often begins not in laboratories, but in the hands of those who refuse to stop working. Today, if you stand on the old airfields of Tinian or Guadalcanal, you can still feel it. The compacted coral beneath your feet, the faint hum of engines in the wind. It's a reminder that sometimes the most powerful acts of war are not destruction, but creation. And in that creation, one graveler's insane process became something eternal, a foundation not just for airstrips, but for human ingenuity itself.